In this problem number 8, the following data are related to the bar subjected to tensile test. We are doing a tensile test. The diameter of the bar is 30 mm or we call as 0.03 mm meter. So tensile load will be P will be 54 kilonewton. Gauge length is L equal to 300 mm. Extension of the bar is delta L equal to 0.112 mm. Change in diameter, this is lateral change, right? Lateral contraction. This is longitudinal stretching length. This is the lateral 0.00366 mm. So find out the Poisson ratio, and Poisson ratio we can call that as mu, or some cases we will call that as n by m. They will give some cases they will give m. So we need to find out the values of three modulus, that is Young's modulus, bulk modulus, shear modulus. That's why they get three modulus, K, E, G and K. Right? Let us start with the problem with the given a bar. Let us consider this is a bar of diameter. Definitely it have the circular bar, prismatic bar. There is no change in the length of the entire bar. So they are testing in the UTM machine. UTM they have the holder. This will be the holder in the machine. This portion they will have holding the machine using the machine. So this is our gauge length. The only testing length is the gauge length, that is L equal to 0.3 meter. Right? So the diameter will be 0.03 meter. Right? Due to the extension of the bar, the lateral stretching will be delta L will be 0.112 mm and the this contraction, right, will be 0.00366. This is delta D. Right? Now from the Poisson ratio we need to solve the problem. So solution Poisson ratio, Poisson's ratio mu or 1 by m we need to find out. For that, stress will be load by area. Stress is applied, stress will be, tensile stress will be, we know, 54 kilonewton. So 54, the area will be pi by d square. We have 54 divided by pi by 4 into 0.03 the whole square. We know the diameter square. So if you do the mathematics here, so you have what are the values? If you go for this 54 into 4, you have some value divided by pi, again divided by 0.303 into, again divided by 0.03. If you do this, you will get 76394.37 kilonewton per meter square. We can call it 76. If you take here 39 into megapascals. Kilo means we change this as mega newton per mm square. Mega newton per mm square. Right? We identified the stress value. Only stress we can find out the remaining term. So we need to find out the linear strain. Change in length by original length. Change in length we have 0.112. Original length is 30. Both are in mm only. There is no problem in cancellation of the unit. 3.37 into 10 to the power of 4 will be the linear strain. So lateral, why? Because we have the diameter, so diameter change, lateral strain will be lateral strain value due to the diameter of the bar. We have 0.066 by diameter 30, 1.22 into 10 to the power of minus 4. This will be your lateral and linear strain. So now we are going for the Poisson ratio. Why we identify this lateral strain means we know the Poisson ratio formula, mu equal to 1 by m, or we called it as lateral strain divided by linear strain. This is a formula, right? We identify this is lateral by linear, not linear by lateral. Kindly note down the lateral by linear. Right? We apply this 1.22 10 to the power of minus 4 divided by 3.73 into 10 to the power of minus 4. If you do calculation, you will get 0.327 of your Poisson ratio value. So we got the value of Poisson ratio. Now only you are going to find out the three modulus. Second one is moduli E, G and K. What is Young's modulus, shear modulus and bulk modulus. That's why we identify the stress value. E will be stress divided by strain. We know the formula, Oakes law. So we found out the stress will be 76.4 megapascal. Our strain will be 3.73 10 to the power of minus 4. So the value is 2.05 into 10 to the power of 5 megapascal. Right? Now, you know the relationship. E equal to 2G 1 minus mu is our formula. So E we know, mu we know. From this we can identify what is G value. Keep this E by 1 plus mu, right? G if you keep 2G. So 2G. G equal to 1 by 2 1 plus mu. You substitute the values and get the G value. So E equal to 2G 1 plus mu is the formula. 2G we keep it as E by 1 plus mu will come. G equal to 2 will come 1 by 2 E into 1 by 2. What is the E value? Find out at 2.05 10 to the power of 5 mega Newton per meter square whole divided by 1 plus what is the mu value? 0.327. So 0.327 is our. If you solve this, you will get G equal to 0.77 10 to the power of 5 mega Newton per m meter square or Pascal. So the remaining term is we need to find out the bulk modulus. Bulk modulus again E equal to we can write it as 3K. 2G E equal to 2G, K E equal to 3K. Find out 3K kids you can remember in different manner. Plus 1 minus 2 mu you can. This is the formula. Now you apply E value, K value and mu value. E value, K value and mu value. For that we need to keep this 3K E divided by 1 minus 2 mu. We need only K. So 1 by 3 E by 1 minus 2 mu. Substitute E 1 by 3 E value will be 2.05 10 to the power of 5 mega Newton per meter square whole over 1 minus 2 times of Poisson ratio. If you solve this, you will get K value equal to 1.9 into 10 to the power of 5 mega Newton per meter square. So we have the result. One is Poisson ratio we find out at 0.327. Second, we identified the value of stress we calculated in this formula. Third one is E equal to 2.05 into 10 to the power of 5 mega Newton per meter square. And fourth one is G value we find out at G equal to shear modulus 10 to the power of 5 mega Newton per mm square. Finally, we identify the bulk modulus K equal to 1.97 10 to the power of 5 mega Newton per mm square. Right? So we'll recall this problem. So they given a circular rod and they are testing in the UTM machine, and with the diameter of 30 mm, the applied load is 54 kilonewton. Gauge length, the measuring length or testing length is our gauge length. It is 300 mm. The extension of the bar, that is, if you apply load in the tensile direction, that gets 0.112 mm, and contraction due to this tensile load is 0.00366 mm. So we need to find Poisson ratio on the three moduli G, K, G and E. And further Poisson ratio we know lateral strain by line to strain by lateral strain. So load, first that we need to find out the load with the given data, and we identify the lateral strain, linear strain, lateral strain, mu Poisson ratio lateral strain by linear strain, mu we calculated, and E equal to stress by strain. Stress we know, strain we calculated, and E we calculated to 2.05 into 10 to the power 5 meganewton square. And we know the relation between E and G and E and K. From that we calculated the G value is 0.77 10 to the power 5 meganewton per meter square. And we know the relation between E and K, Young's modulus and bulk modulus, that we calculated K equal to 1.97 10 to the power 5 meganewton per meter square. The results are we identify the 5 terms: mu, Poisson ratio, stress, Young's modulus, shear modulus and bulk modulus. Thank you.